Joule Thomson experiment or porous plug experiment. Joule and Thomson in 1952 they devised a technique which is known as porous plug experiment to explain the existence of intermolecular attraction between the molecules in real gases. Principle of porous plug experiment or Joule Thomson experiment. The principle, it consists of forcing a gas at a constant pressure through porous plug thermally insulated from outside. Porous plug consists of material like cotton wool or silk having large number of holes or pores. So this porous plug, it is made up of cotton wool or silk having large number of holes or pores. The gas on passing through the porous plug under large drop of pressure gets throttled. That means the molecules after passing through the porous plug get further apart from one another. Before passing through the porous plug, the molecules were very close to each other. After passing through the porous plug, the molecules move away from one another. So the gas, for this to happen, the gas has to do some internal work to overcome the intermolecular attraction. This work will be taken from the internal energy of the gas itself, since no heat is supplied to it. Since the gas uses its own internal energy to overcome the intermolecular attraction, the gas on passing through the porous plug will suffer fall in temperature. So the cooling of gas, it was demonstrated by Joule and Thomson in their famous porous plug experiment, and hence it is called as Joule Thomson effect. Description of the apparatus. This is the apparatus used in porous plug experiment. The gas under test is compressed using a piston P to a high pressure, and then the compressed gas, it is passed through a long spiral tube S which is immersed in a water bath. The temperature of the water bath is kept constant. The compressed gas, it then enters tube B which is fitted with porous plug G which is made up of cotton or silk having large number of fine holes. The plug is connected between two perforated brass discs D and D. A vessel L is fitted with a cotton wool which surrounds the tube B. The vessel L, which is made up of fitted with cotton or wool, it surrounds the tube B, which gives a good thermal insulation to the porous plug. When the gas flows through the plug, it will experience large drop in pressure. That is, when the gas passes through the porous plug, the molecules get further apart from one another. So the gas has to do some internal work to overcome the intermolecular attraction if it exists. So this work will be done from the internal energy of the gas itself, and therefore on passing through the porous plug there will be a drop in pressure. When the flow becomes steady, the temperature of the gas on both the sides of the plug are measured with the help of platinum resistance thermometer, and it is taken as T1 and T2. The pressure of the incoming gas is measured by a instrument which is called as manometer, while the pressure of the outgoing gas will be equal to the atmospheric pressure. The behavior of large number of gases, it was studied over different ranges of initial temperature. So it was found that in general all gases, they showed change in temperature in passing through the porous plug, and this effect is called as Joule Thomson effect. The results of porous plug experiment. First one, all gases show a change in temperature on passing through the porous plug. So this effect is called as Joule Thomson effect. Second one, the change in temperature, it is proportional to the difference between the pressure on two sides of the plug. That is, the pressure of the gas before passing through the porous plug and the pressure of the gas after passing through the porous plug. Third one, at ordinary temperature, most of the gases, they show cooling effect, but hydrogen show heating effect. For every gas, there is an inversion temperature. So at this temperature, there is no heating effect or cooling effect on passing through the porous plug. So at inversion temperature, there will be no heating effect or cooling effect. If the initial temperature of the gas is less than inversion temperature, the temperature of the gas falls on passing through the porous plug. And if the initial temperature of the gas is more than the inversion temperature, the temperature of the gas, it rises on passing through the porous plug.